Hello students, welcome to EPG Pathshala. I am Vinodini Kapoor from Chandigarh and I am teaching in the Faculty of Management. Today we are going to discuss about the module System Development Life Cycle under the paper of Management Information Systems. Now after completing the module, the students will be able to understand the concept of System Development Life Cycle and its objectives, understand what are the various stages or phases in the process of SDLC, understand different modules of SDLC and their respective advantages and disadvantages. They will be in a position to list what are the various guidelines to be followed in building effective information systems and understand what are the applications of the SDLC process. The chief executive of a company asks to find a web-enabled way to get information to and from the sales force in the company. What would be the best approach? Could there be a systematic way to develop a good solution to the CEO's request? This problem-solving process is called the systems approach. When the systems approach to problem solving is applied to the development of information system solutions to business problems, it is called information system development or application development. The overall process by which information systems are designed and implemented within the organization is referred to as system analysis and design. Within this process are contained activities that include identification of business problems, the proposed solution in the form of an information system to one or more of the problems identified, and the design and implementation of the proposed solution to achieve the desired and stated goals of the organization. The most common approach are objective-oriented analysis and the life cycle approach. System life cycle is an organizational process of developing and maintaining the system. It helps in establishing a system project plan because it gives the overall list of processes and sub-processes that are required in developing a system. SDLC means combination of various activities. To sum up, we can say that the various activities when put together are referred to as system development life cycle. Let's discuss the objectives of the system development life cycle. Firstly, documenting requirements and maintaining traceability of these requirements throughout the development and implementation process to ensure that projects are developed within the current and planned information technology infrastructure, to identify project risks early and manage them before they become problems, delivering quality systems that exceed expectations when promised and within cost estimates, ensuring that system development requirements are clearly identified and subsequently satisfied. It segregates the entire life cycle, making it easier to process and evaluate each part of the system development. We now discuss the phases of the system development life cycle. There are 7 phases in the SDLC life cycle, the first being system investigation. This stage determines how to address business opportunities and priorities. It involves conducting a preliminary feasibility study to determine whether a new or improved business system is a feasible one. It also involves development of a project management plan and management approval.
Feasibility studies are a part of the system investigation phase. The process of development can be costly. Hence, system investigation stage typically requires the development of a feasibility study. This is a preliminary stage where the information needs of prospective users and the resource requirements, cost, benefits, and feasibility of a proposed project are determined. Operational feasibility. It refers to how well the proposed system supports business priorities of the organization, how well the proposed system will solve the identified problem, how well the proposed system will fit with the existing organizational structure. Technical feasibility. It refers to the hardware, the software, and network capability, reliability, and availability. The legal or political feasibility in context of the system development life cycle shall refer to the patents, copyrights, and licensing. It also deals with the government restrictions, the stakeholders, and the reporting authorities. Economic feasibility, cost saving, increased revenue, decreased investment requirements, cost benefit analysis, increased profits are among the few parameters that deal with this. Human resource feasibility, employee, customer, supplier acceptance, management support, determining the right people for the various new or various revised roles. The second phase in the SDLC process is system analysis. This stage involves analysis of the information needs of employees, customers, and other business stakeholders. Further, it deals with the development of functional requirements of the system and can meet business priorities and the needs of all stakeholders. It enables to develop logical models of the current system. The second stage, or the step of development process of MIS, it is applicable to both for making an entirely new system or improving an existing one. Analysis involves knowing the information needs of the end user and the organizational employees, what are the resource activities and products presently available, and information system capability to meet the information needs. Organizational analysis. It refers to effectiveness in MIS. It is imperative to show about the organizational culture, the management qualification, values, norms, etc. Present system analysis. In case the company has some information system in existence, it is essential to analyze that system from its perspective. Functional requirement analysis. These are end user requirements that comprise user interface requirements, processing requirements, that is, decision rules, calculations to convert input to output, storage requirements, and control requirements measuring accuracy, validity, safety, security, and adaptability. The third phase refers to system design. The process of system design involves development of specifications for the hardware, the software, people, network and data resources, and the information products that will satisfy the functional requirements of the proposed business information systems. System design consists of design activities that ultimately produce physical system specifications satisfying the functional requirements. It is in this phase where development of the logical modules of the system takes place. This stage answers how the system will accomplish the objectives. System design consists of activities that produce system specifications and satisfying functional requirements in analysis stage. Conceptual design. It represents the structure of management information system. It takes input from MIS and the output is performance requirement of those who will develop the detailed design. Detailed design. The design of the system becomes more structured. Input, output, databases, forms, codification, schemes, and processing specifications are drawn up in detail. In the design stage, the programming language and the hardware and software platform in which the new system will run are also decided.
Coming to the fourth step in the phases of the system development life cycle, the system implementation phase. It involves acquisition of the hardware, the software development, the testing of programs and procedures, further conversion of data resources, and a variety of conversion alternatives. It also involves the education, the training of the end users and the specialists who will operate a new system. It is essential to manage the effects of system changes on the end users. The major steps involved in this particular phase are the acquisition, the installation of hardware and software, the conversion, the user training, and the documentation. The hardware and the relevant software that are required for running the system must be made fully operational before its implementation. The conversion is also one of the most critical and expensive activities in SDLC. The data from the old system needs to be converted to operate in the new format of the new system. The database needs to be set with security and recovery procedures that are fully defined. During this particular phase, all the programs of the systems are loaded onto the user's computer. Now, after loading the system, training of the user starts. The fifth phase is the system maintenance phase. Now, this phase involves the use of post-implementation review process, and this is essential to monitor, to evaluate, and modify the business system as needed. It involves control, evaluation, and modification to make a better system. The maintenance activity is initiated by error reports, a user change request, a member of maintenance team or management. Maintenance is necessary to eliminate errors in the system during its working life and to tune the system to any variation in the working environments.
We now discuss different models of system development life cycle. A while ago, system development considered of a programmer writing a code to solve a problem or automate a procedure. Nowadays, systems are so big and complex that teams of architects, analysts, programmers, testers, and users must work together in creating the millions of lines of custom written code that drive the enterprises. Due to that different types of projects have different requirements, it may be required to choose the system development lifecycle phase according to the specific needs of the project. First and foremost, we discuss the waterfall model. This consists of different stages that are processed in a linear fashion. The first being the requirement stage. It is the phase where the what of the software system is defined. It involves extensive user participation and ends with an approved set of requirements documented in a software requirement specification document. The next is the design phase. The how of the system is defined here. The problem definition is translated into design which will solve the problem. This phase is a bridge between what the user wants and the code that will be created to satisfy the requirements. Coding. The code is written during the coding phase. The software design is realized as a set of program or program units. Testing. The code that is developed is tested during this particular phase. It involves unit testing for the lowest level of components, integration testing for groups of components, and testing the system as a whole. The last activity is usually the acceptance testing. Operation. The system rolls into the operational and maintenance phase. During this, the leftover defects are corrected. If the system is made more efficient, new requirements are added and existing functionality and features are modified. Maintenance. Now the system rolls into an operational and maintenance phase. The leftover defects are corrected and the system is made more efficient. New requirements are added and existing functionality and features are modified to meet changing business needs. The waterfall model has certain advantages and disadvantages. The advantages of this model are well-defined phases with well-defined inputs. It recognizes the sequences of engineering activities that result in the software platform. It allows departmentalization and control. A schedule can be set with deadlines for each stage of development, and a product can proceed through the development process model phases one by one. Development moves from concept through design, implementation, testing, installation, troubleshooting, and ends up at operation and maintenance. Each phase of development proceeds in strict order. The disadvantages. Real projects rarely follow the sequential flow that the model proposes. The model assumes that requirements are clearly specified at the beginning of the project. The model has no mechanism to handle changes to the requirements that are identified because of design and construction activities or user feedback. The model reduces the user involvement between design and testing phase of the project. For large projects, the users have to wait a long time for the delivery of the system. The assumptions that all requirements are to be known at the beginning in sufficient detail lead to premature decisions because it is difficult to estimate resources accurately when limited information is available. The second is the V-shaped model. Now, this is an extension of the waterfall model, but instead of moving in a linear way, the process steps are bent upward after the coding phase to form the typical V shape. The major difference between V-shaped models and waterfall model is the early test planning in V-shaped model. Advantages. Simple and easy to use. Each phase has specific deliverables. Higher chances of success over the waterfall model due to the development of test plans early on during the life cycle. It works well where requirements are easily understood. Verification and validation of the product in early stages of product development. Let's come to the disadvantages of the V-shaped model. It's very inflexible, like the waterfall model. Little flexibility and scope of adjustment is difficult and very expensive. A V-shaped model doesn't provide a clear path for problems found during the testing phase, costly and required more time in addition to detailed plan. The third model is the prototyping model. It refers to the activity of creating prototypes of applications. For example, incomplete versions of the problems being developed. Prototyping is the process of building a model of a system. In terms of an information system, prototypes are employed to help system designers build an information system that are intuitive and easy to manipulate for end users. It is used to visualize some component of the system to limit the gap of misunderstanding the customer requirements by the development team. This will also reduce iterations that might occur in waterfall approach and hard to be implemented due to inflexibility of the waterfall approach. So, when the final prototype is developed, the requirement is considered to be frozen. The advantage of the prototype model is that it reduces time and cost, but this can also be a disadvantage if the developer loses time in developing the prototypes. Secondly, improved and increased user involvement is again of paramount importance. The disadvantage of this model is insufficient analysis, user confusion of prototype and finished system. Secondly, developer misunderstanding of user objectives, excessive development time of the prototype, expense of implementing prototyping. Spiral model. The fourth particular model is about combining elements of both design and prototyping in stages in an effort to combine advantages of top-down and bottom-up concepts. This model of development combines the features of prototyping model and the waterfall model. The spiral model is favored for large, expensive, and complicated projects. This model uses many of the same phases as the waterfall model in essentially the same order, separated by planning, risk assessment, and the building of prototypes and simulations. It is used in shrink wrap large applications and systems which built in small phases or segments. The advantage of the spiral model is that estimates, such as the budget estimate, become more realistic as the work progresses because important issues are discovered earlier. Also, early involvement of developers. It helps to manage risk and develop systems into phases. The disadvantages: high cost and time to reach the final product. Also, this particular model needs special skills to evaluate risk and assumptions. The highly customized or tailor made attributes make reusability very limiting.
The fifth model of system development lifecycle is the iterative and the incremental method. This is developed to overcome weakness of the waterfall model. It starts with the initial planning and it ends up with development of the cyclic iterations in between. The basic idea behind this method is to develop a system through repeated cycles, that is, iterative cycles, and in smaller portions at a time, which are suggested by the incremental approach. This allows the software developers to take advantage of what was learned during the development of the earlier parts or versions of the system. It is used in shrink wrapping applications and large systems that build in small phases or particular segments. Also, can be used in system and has separated components, for example, the ERP system. It can start with the budget module as first iteration and then we can start with inventory module and so on and so forth. Now let's look at the advantages of this particular model. First and foremost, it produces business value early in the development life cycle. Secondly, better use of scarce resources through proper increment definition. Thirdly, it can accommodate some change requests between the increments. Fourthly, more focused on customer value than the linear approaches, and it allows problems to be detected much earlier. Now let's look at the disadvantages of the model. Firstly, it requires heavy documentation. It's important to follow a defined set of process. It defines increments based on functions and feature dependencies. Secondly, It requires more customer involvement than the linear approaches. Partitioning the functions and features might be problematic. Thirdly, the integration between the iterations can also be an issue if it is not considered during the development phase.
The sixth model is the Agile development model. It is based on iterative and incremental development where requirements and solutions evolve through collaborative functionality between cross functional teams. It can be used with any type of project, but it needs more involvement from customer and to be interactive. Also, it can be used where the customer needs to have some functional requirement ready in less than 3 weeks. The diagram of the agile development lifecycle can be observed. It goes through stages such as project selection and approval, project initiation, construction, iterations, and finally the product release. Each of the iterations will comprise the designing, the coding, and the testing. Advantages of the agile development lifecycle model are decrease in the time required to avail some system functions, face to face communication, and continuous inputs from customer representatives leave no space for guesswork. The end result is high quality software in least possible time duration and satisfied customer. There are also disadvantages to this model, which are in terms of the scalability being limited, ability of customers to express user needs. The documentation is done at later stages, which tend to reduce the usability of components. There are special skills needed for the team or software developers. We now discuss a case study of centric consulting, where the goal was to achieve a better, a faster, and a cheaper service. The business need, a leading US regional bank has grown through acquisitions. The technology organization has been working with processes from days when they were a small community bank. The audit team identified that technology projects were not done consistently or with any repeatable or sustainable process methodology. Additionally, the business community was looking for technology to drive and deliver quality within all systems deployed within the bank. Centric's high impact approach. The client partnered with Centric to develop a system development lifecycle methodology to help them manage the tremendous growth in technology projects. The focus was on the additional complexities of enterprise deliverables while delivering technology and quality services, developing a system which was better, faster, and cheaper. The result, the solution allowed the client to meet their delivery commitment to audit and their business customers on time and exceed expectations. A requirement manager methodology to focus on capturing requirements from all particular stakeholders in a thorough, repeatable, and consistent process. Development of a technology management methodology to focus on designing and building enterprise technical solutions and introducing cost and bills of materials for those solutions. Development of a quality management methodology to focus on testing strategies to ensure quality being tracked and traceable form of capture of requirements through designing, building, testing, and transitioning to production. Integration of three processes, deliverables, and timings to deliver a comprehensive SDLC methodology. Training for the use of the process, use of templates, and deliverables of the technology users. We shall now discuss what are different considerations in SDLC in building information systems. There are guidelines that are to be kept in mind in context of system development lifecycle for building effective information systems. Firstly, follow the STLC phases sequentially in order by completing one phase before commencing the next. It is imperative because when phases are bypassed or rushed, you can expect problems with the developed information system. Secondly, by understanding all the requirements will create a better design. And a good design further helps to avoid problems in later stages, such as during construction. It is very cost effective to complete one phase before moving to the next to reduce the chances of rework. However, it is essential that while you work on a particular phase, you also should consider the impact of your decision on the later phases. The ability to overlap phases is especially important when you are working on a system that must be developed rapidly. Powerful project management tools and techniques are available to help you manage multiple tasks in system development process. Further, focusing on the end product. Each end product or deliverable represents milestones or checkpoints in the system development, and these mark completion of the specific phase. Management uses these particular checkpoints to assess the status of the project and decide what should happen next. Possible choices are to proceed to the next phase, redoing portions of the work that have just completed, return to an earlier phase, or terminate the project entirely. One of the major factors that influence or help in management's decision is the quality of the end product. Thus, the document should strive for long content and high quality. Further, we discuss how to estimate required resources. The management needs to know the cost of developing and operating the proposed information system. Cost estimation at the start of each phase and successful phases, as well as operation cost estimate, is essential to undertake critical business decisions. This is very helpful in resource and budget allocation.
Okay, students, now let us summarize what we have learned in this particular module. There are a variety of SDLC models and frameworks. However, choosing the right model is a key factor and it is dependent on various conditions and scenarios. Prima facie, the requirements of the system play a very key role. Requirements that are strict and immutable may lead to adoption of a waterfall approach. Now, but if the requirements are expected to change very often or are not clearly defined at the start, the team will probably adopt a more agile or iterative approach. Secondly, the deadline for the development of the system is also an important factor. It is clear that if the schedule is tighter, a rigid step-by-step model based on the extensive documentation and late testing would be unreasonably slow, thus excluding the waterfall models. The project's dimension is one of the most influential factors. More extensive the project, the more rigid the model tends to be, because a large team comprised of many developers will make agile responses much more complicated. The location of the team is also a main factor. If the team involved in the project are geographically dispersed, a waterfall-like model is probably the best approach for the clarity of its stages and tasks. In agile development, where a tight communication is important, it is an approach that is more beneficial to small teams working closer together. Choosing the right model is the most tactical step of the system development process. As information systems continue to be fundamental to modern business and organizational setups, the SDLC models will also continue to be built, researched, and utilized. Thank you.